Okay, we're going to be calculating the line of best fit. These are the steps. You can see them on your notes. I'll be referring to them here in a minute on the calculator. All right, here is our data. And I've got the light on so you can see my calculator. So you can't see the notes as well, and I apologize about that, but you're going to want to see what I'm doing here. All right, what we're going to do is we're going to find the line of best fit for this table of data. And usually we use y equals mx plus b, which is fine. We're still going to use that. But in the calculator, it's written a plus bx. And the b is not the y-intercept, it's the slope, because it's in the calculator, the b is with the x, which is the slope, and the a is the y-intercept. So anyway, you're going to load this data. You're going to hit mode, and you're going to hit number 3, which says stat. And then you're going to hit number 2, which says a plus bx. And then you're going to load your data in. So this is my x. I'm going to go down through here and put my x's in. I've got 9, 13 is the next one. I'm going to step away and let you look at this data as I type it in. And I'm just going to go through here typing in this data. You hit the number, hit equals, hit the number, hit equals, and just keep going down the data. Now, the one thing that you have to be careful of is you have to be careful that you have the same number. I have 11 pieces of data, and this is 11 numbers down through here. Now, to get to my y, I'm going to scroll right for the y, and then I'm going to hit the up button, and that takes me to, usually I meant to hit down, but anyway, there's my first one. So I'm going to hit 260, hit equals, then I'm going to hit 320, hit equals, and I'm going to keep going. I'm going to step away so I can do this faster so that you can see the data. You want to make sure that your data matches. See how I have 11 numbers on the left and for the x and 11 on the right. All right, now this next step is going to be kind of spooky. And, of course, this is on that slide, a couple slides back where it taught you where the steps were. But you're going to hit AC. Then you see on the 1 in yellow it says stat. So you're going to hit Shift 1. And then you're going to hit 5 for regression. That's called linear regression. That's what it stands for. Then we want to find our A. So we're going to hit 1 and hit equals. And it gave me an A of 193.8. And you see I already have that on the notes. Then I'm going to hit AC again because I'm going to have to find the B. So I hit AC. I'm going to go Shift 1 again. Hit 5 for regression. Then I'm going to hit 2 to find the B. And remember, B is your slope in the calculator. So my line of best fit is y equals 11.7x plus 193.8. Now, there is also an R on here. So that's the linear the correlation coefficient. So I'm going to hit Shift 1, hit the 5 again. This time hit 3. That gives me the R. And that tells me how tight and how good my line is. My equation is 0.97. It has an R of 0.97, which is a really good linear correlation coefficient. All right, and we'll talk about that in a minute. All right, here we're making a table. We've got 10, 7, 20, 10, 30, 14. You just look at the points here and label them off the side. Make yourself a table. And then put them in the calculator again, and you get the line of best fit of y equals 0.45x plus 1.7. Again, you're getting your A and your B the same way that we did on the other data. All right. Let me make sure that my video is still working. It is. Okay. We have correlation coefficients here. We have perfect positive, which is 1. We have a high positive correlation, which is 0.8. And notice that for it to be positive, it's going up as it goes from left to right. And then 0.3 is a low positive correlation. That's how come I knew when I got 0.97 on that problem earlier that I had a really strong positive correlation. If the dots are everywhere, that's no correlation. A low negative one, this is going down and they're spread out, and it's got a correlation coefficient of negative 0.3. This one is high, but it's negative as well, and this one is perfect negative correlation. All right, now, what a correlation coefficient does is tell you how strong the linear model that you've come up with is. How strong is it? And if you look, here's an example of graphs with a line going between them. This is very strong. Nearly every point is on the where they're on the line. Some of them a little below or a little above, but it's still there. This one here, you see the line going through it, and the plot's wider, and so that's a weak one. And this one is strong. They're all tight around the line. That's a negative one, but it's strong. So the closer to 1 that it is, or negative 1 that it is, the stronger the correlation. The closer to 0.5, then the weaker that the correlation is. Thank you.